Good evening, everyone. I'm Shafali Agarwal. I'm a research scholar at IT Madras in Civil Engineering Department, and today is our fifth TA session on the topic of basic construction material. So, in this week, we have actually worked on the cement first material of our concrete structure, cement and concrete. So, an overview of outline of this week will be we have worked about the construction with concrete and what are the different type of concrete we are using in our construction industry, like mainly plain concrete, reinforced concrete, precast concrete, and 3D printed concrete. And then what are the different materials which are being used to make the concrete, mainly the Portland cement, aggregates, chemical admixture, and mineral admixture, and what are the different properties of these construction material. So we have talked about in depth about the Portland cement, how cement is produced, what is the composition of our cement, main hydration products, then what are the different tests which have to be done on cement, and how the cement is classified based on the different coded provisions. And then next thing is about the aggregates. So what are the different classification of aggregates in concrete sources, properties, and then about the chemical admixture which are usually used in the concrete system. Mainly about the plain reinforced concrete system and the mineral admixtures overview. So if we start with the basic thing is like when we are constructing anything with the concrete, we know that our concrete is strong in compression, however, it is weak in tension. So if we have to use this kind of concrete in our normal structure, then we are providing our steel rebars in the tension zone so that our structure is safe in both compression and tension. So why we are using steel rebars only? Because it have a similar coefficient of thermal expansion as the concrete material. And also there are many other different type of reinforcement coming up like fiber reinforced concretes and then textiles. Those are the recent development in the reinforcement which can be used in the concrete system. So next thing is what exactly is a concrete? So if we talk about concrete, it is a composite material composed of mainly two things. First is the cement paste, which have cement and water, and then aggregate, which are usually classified as coarse and fine aggregates. So this is a chart where we are telling that what are the main components of our concrete. We are using cement, then we are using fine aggregates, coarse aggregates, admixtures, and water. So almost two-thirds of our cement consists of coarse aggregate, and if we see the total aggregate content, it is more than 70%. So almost 70% of our concrete consists of aggregates. So next thing is if we understood what exactly is concrete. So what are the different type of concrete which we are dealing with? First is the plain concrete. So if we see on the roads and mainly which are not what is it structural elements which do not take up the loads, there we are using plain concrete. So mainly like roads or this is just a park area, stairs area where there is no provision of taking up the loads from the superstructure. Next is the reinforced concrete structure. So whenever we are designing multi-story building, when we have beams, columns, and we are using, we have different type of loading, then we are using reinforced concrete. So why we are using reinforced? As we have explained. Steel will be good in tension, whereas concrete is weak in tension. So that's why we are using reinforced structure with a concrete. Next thing is precast concrete. So precast concrete is mainly which concrete which is then casted on the which is not cast on the site. It had been cast in the industry, and then different elements are taken to the site, and they are just joined together using different techniques. So other type of concrete, emerging type of concrete is the 3D printed concrete. So if we talk about 3D printed concrete, it's a fully automated thing. We don't need labors, and we can have different type of shapes and sizes. And it's like just a similar kind of concept as precast concrete. You are building up all the elements in the industry and then taking it on the site and then finishing it on the site, you connecting different elements. So these are the different type of concrete which have been used or are the emerging type of concrete which can be used in the construction industry. So next topic is the first of the main element of our concrete, cement. So we will be talking about cement. So if we talk about cement, the main raw material of our cement is diaterial, calcareous, and argillaceous materials, uh, which actually form the cement. So the main elements of our cement are given here. Mainly, we are using limestone, which which is calcium oxide, and it will be the maximum almost 50 to 60% of cement consists of limestone. Then we have silicon dioxide, aluminium oxide, which is almost 20 to 30%. Then iron oxide and magnesium oxide. So these five are the main elements of our cement. Other than this, we are here you can see different kind of other raw materials or other waste material which can be the source of these type of these raw materials. So if we talk about calcium, so generally we are using limestone as a source of calcium. However, instead of limestone, marl, calcite, shale, seashells, these all things can also be used as the sources of calcium. Same way, if we talk about silicon, silicon we are actually using as of now clay, or we will use sand. Other than this, we can use some esteem like fly ashes, slag, rice husk ash, it should be husk, rice husk ash. And then coming the aluminium content of our cement. So we are using clay, shale, fly ash, aluminium ore, and the last thing is the about the iron content. So iron content can be coming from the clay, iron ore, shale, blast furnace, dust, etc. So, if we talk about the production of a cement, how a cement is generally produced is the we are taking from the limestone quarry. Limestone is being collected, and then it is being break down into small particles. We are grounding a limestone in a very minute particles, and then we are adding our slag and sand to it and preparing it, grinding it. And after grinding, we will be heating it in the kiln. So after heating in the kiln, what we are getting is the clinker. So we are calling it as a clinker. And this clinker is further cooled down to make the normal cement which we are shipping it to the sites. So these are the different steps which are being used to produce a cement. And if we talk about the cement, normal cement composition, so as we have seen in the previous slide, we have source of calcium, silicon, aluminium, and iron. So mainly oxides of these four materials will be available in bulk. Other than this, we have magnesium, some minor oxides like magnesium sulfate, sodium, and potassium. So these are the normal oxide composition of our cement. Other than these, combining these different oxides, we have some compounds which are formed in a cement. like C3S. If we talk about C3S, what it is 3 times calcium oxide and 1 time silicon oxide. So same way C2S will be 2 times calcium oxide and 1 time silicon oxide. So combining these oxides, we have different compounds of our cement, and these are the main four compounds of our cement, and how much quantity of these compounds will define our properties of cement. So if we talk about different classification of cement. So based on the quantity of these compounds, we are classifying as our cement in different categories. So this is the classification based on ASTM type. So ASTM is defining when you have 45 to 55% of C3S, 20 to 30 of C2S, 8 to 12 of C3, and 6 to 10 of C4S. Then we are calling it as a type 1 of cement. Same way, depending on the composition of our different compounds, we can define the type of cement which we are using. Other than this, we are actually classifying in another way, that is a this is a BIS method. So this is a BIS method of classification where we are classifying as cement as ordinary Portland cement (OPC), then Portland cement which have low heat, rapid hardening cement, pozzolana cement, or slag cement. So also in these type of different cement, we will have different composition of our compounds present. So how other than this, we have different extra type of classification of cement. So this is a graph of expensive cement. So where usually we are using expensive cement when we have chances of shrinkage, more chances of shrinkage, more chances of plastic shrinkage. In that cases, we are using expensive cement. Then we have this is high alumina cement. So high alumina cement is also called as calcium sulfur aluminate cements. So these are the new type of cements which are coming up. So what is the advantages of this? What we say? Advantages of high alumina cement? Anybody? So if we are using high alumina cement, there are chances that our strength, like from this graph, if you can see, we have a higher strength as compared to ordinary Portland cement. Also, there are chances of low heat of hydration or slow reaction or anything like that. So that is the high alumina cement. So it usually have like if we are using in acidic environment, if we are using our concrete in acidic environment, in that cases we are using calcium aluminate cement or high aluminate cement. Why we are using high aluminate cement in the case of acidic environment is sorry because at higher temperature, these type of cement have a good performance as compared to a normal ordinary Portland cement. So next thing about cement is hydration of our cement. So this is a normal hydration curve of our cement. So what exactly hydration means? When we are adding water to cement, the reaction which are happening, that is called as hydration of cement. So it is divided into 5 phases. First is the initial heat, and then we have the second curve, and then dormant period, acceleration period, and retardation period. So how the different type of reactions are happening at different stages is called as the hydration of cement. So initially we are telling that C3S and C3A, these are the most reactive components in our concrete in our cement. So these are the whenever we are adding water to cement, these will react with the water and form the hydration products. So what are the main hydration products we have is like CSH, calcium sulfur CSH. Then we have sulfuric, sorry, not sulfuric. Then we have CH, calcium hydroxide, COH. 2, then if we have too much of C3A, we have too much of aluminates, then there are chances of formation of etrinite. So this is a complete step how when we are adding water to different compounds, how nucleation will happen and how hydration of cement will take place. So other thing about cement is like what are the different tests we are doing on our cement. So these are the normal tests which we actually do on cement is first is the normal consistency of cement. So what apparatus we are using? We are using Vickert apparatus for testing the consistency of cement. So consistency will tell us about the how much water we can add to a cement, and from that we can calculate the setting time of cement. So we from the same apparatus Vickert apparatus we have three type of needles or plunges, three type of plunges which will define us the consistency, initial setting time and final setting time. So from the same apparatus we can calculate the normal consistency as well as the setting time of our cement material. Next is the soundness. So soundness will tell us about the unhydrated lime or magnesium in our concrete. So for soundness, we are using this Leach Atelier apparatus. So I think you guys might have already seen in your lab. So we are adding the cement paste in this and we are checking how much expansion is happening in the two props. Okay. So next is the air permeability. Air permeability will tell us about the fineness of our cement, and this is the apparatus for air permeability. Uh, Other than this test, we have other test for fineness that is using the sieve analysis. So we can use sieve analysis, and the main sieve used for the cement paste, raw cement is the 90 micron sieve. Uh, Other than this, we can test the specific, we can get the specific gravity of cement, and last and least is the compressive strength on the mortar. So we cannot get the compressive strength on our normal cement paste, so we actually always calculate the compressive strength on the mortar. Mortar is mix of cement, sand, and water. So these are the different type of tests which we perform on the cement. So next important material in our concrete industry is the aggregates. So as we have discussed in the first slides, almost 72, almost 70 to 80% of our concrete consists of aggregates. So it is important to have a good aggregate in our concrete system. So we usually define it in the two things, fine aggregates and coarse aggregates. Fine and coarse aggregates. So if you see from this figure, you can easily identify the sand. Usually the sand is called as the fine aggregates, and all the other solid aggregates are called as the coarse aggregates. So which is the sieve which actually define fine and coarse aggregate is the 4.75 mm sieve. So if your aggregates are less than 4.7, then we are calling it as fine. If it is more than 4.7 mm, then we are calling it as a coarse aggregate. Okay. So other than this, what are the different tests of aggregates which we should do before doing before concreting is crushing strength for aggregates. Then how we are calculating the crushing strength? Dear. So we are using actually the normal compressive strength testing machine, and we will fill the mold with all the aggregates, mainly coarse aggregates, and then we will do the crushing strength value of this. Then we have the modulus of elasticity. Other than this, we can calculate the hardness, impact value, and the crushing resistance of our uh, force aggregates. So, and then same way specific gravity and what are the different gradations of our aggregates. So why gradation is important? If you see from this figure, these are all the coarse aggregates with no fine aggregates. So what will happen whenever we are mixing it with the concrete? There are chances that there are some pores inside the our matrix, our concrete matrix, because these aggregates are not fully occupying the space. So these pores or these gaps will weaken our system, and there are chances of crushing of our concrete. Same way, so that's why we are telling it should be. If you see this figure, this is a well graded system. We always say that our system should be a well-graded system. So in well-graded, we have all type of aggregates from small sand to bigger aggregates, and it should be mixed properly. It should not be like separated out. So that is called as the gradation of our cement. Sorry, of our aggregates. Next thing is the bulking of fine aggregates. So whenever we are adding water to our sand, there are chances that sand will expand. So it can create a issue in the concrete. So that's why we have to check the bulking of our fine aggregates or bulking of our sand before starting the test. And other tests are soundness tests and what are the presence of impurities in our aggregates. So these are the main tests which we are performing on the aggregates. So next thing, next material which we are using in our concrete system is the admixtures. So we have chemical admixtures and mineral admixtures. So whenever we are using some chemical compounds or any organic chemical compounds, we are calling it as chemical admixtures. If you have seen mainly the superplasticides, we are calling not we are calling it as superplasticizer, but main chemical admixture which has been used on the industry is the superplasticizer. So whenever we are using some chemical compounds, it can be water reducer, it can be superplasticizer, or it can be air entrainer. Air entrainer we are using when we want some gaps in our concrete, mainly when we are using it for the freeze, like area when we are making the concrete in the area of snow. So what will happen? Water will store inside the gap, and it when it will expand, there are chances that concrete will break through it. So that's why we are adding air and inner admixtures. So it will create some bubbles inside the concrete and so that it won't expand and break over. So these are the main chemical admixtures which we are using. Other than this, if we talk about from the durability point of view, then we have major issue of corrosion. Then we are using corrosion inhibitors. So these are also one of the type of chemical admixtures. So, other than this, what are the other mineral admixtures which can be used as the alternative to fine aggregates or can be used as an alternative to cement? So, fly ash, like already it is being marketed as PPC cement, porcelain of portrait cement, GGBS. Then we have silica fume, metakaolin, then ashes, different type of ashes we have. So rice husk ash, and so these are the mineral admixtures which are used as a cement replacement. They can improve strength, or if they are not improving strength, there are chances they can do poor refinement of our concrete. And so what they have, like depending on the need, we are using different type of admixtures, chemical or mineral. Whatever we need, we can use that type of admixtures in our concrete system. So this is a typical composition of different type of mineral addition. So if we talk about normal Portland cements, we have almost 65% of calcium oxide and 20% of silicon oxide and 5 to 2% of aluminum and iron oxide. So if we are using other admixtures, how these properties or how this compound values will change is the showing here in the typical composition. So this is a little overview of week 5. If you guys have any doubt, you can ask me now. Otherwise, we will see few questions on this week. Okay, if there are no doubts, then we will go to the question and answer session. So the first question is, choose the material which has similar coefficient of thermal expansion as that of concrete. Steel, bamboo, plastic, paper. So this is an obvious answer. We answered in the first slide itself. So answer is steel. So that's why we are using steel as the reinforcement in our concrete system because it has a similar coefficient of thermal expansion as that of concrete. So if we see different coefficient of thermal expansion, if our concrete thermal coefficient lies in the range of 10 to 14 into 10 to the minus 6 per degree Celsius, steel is almost similar of 11 to 13, bamboo have 4 to 6 value, plastic have a very high thermal expansion 50 to 250, and paper have 10 to 40. Okay, so the answer is D. Okay, so the next question is, which of the following compound in cement contributes to the early strength development? Tricalcium silicate, dicalcium silicate, tricalcium aluminate, or tetracalcium aluminoferrite? This is C4A. This is C4A. So mainly early strength is because of tricalcium silicate. C3S is the having high silica content because of high calcium oxide content. It will contribute to early strain development. If we see from the even from our hydration curve, this acceleration period is mainly due to the hydration of C3H, which contribute to the higher early strength in the concrete system. Okay. So the next question is, what is the primary function of gypsum in cement manufacturing? It acts as a binding agent, it increases the strength of the concrete, controls the setting time of cement, or it controls the rate of hardening of cement. So if we see a normal cement manufacturing thing, we are collecting the lime from the lime quarry, we are crushing it, and then we are adding sand and clay in a proportion to it, grinding it again, reheating, and then uh, keeping it in cement kiln, and then we are producing clinker, which is cooled down, and then after cooling down of clinker, we are adding gypsum to it and again grinding it. So before final grinding, we are adding gypsum to it. So what exactly is the function of this gypsum? Why we are adding at this point? See, it's act as a binding agent. No, already clinker is formed. Strength of concrete? No, we are adding it in the manufacturing process of cement, so it cannot affect the properties of our concrete. Control the setting time of cement? No, because no water is added at this point, so we cannot say it is controlling the setting time of cement. As is the control the rate of hardening of cement. So this is the correct answer. When a clinker is cooled down and it is grinded, there are chances of formation of lumps. So To control that formation, lump formation, we are adding gypsum to it so that it will remain as in a powder form during grinding process, final grinding process. Okay, so the answer is D. Okay, so the next question is, which phase of cement hydration involves the rapid formation of ettringite? So we have five phases. Okay, I have already given the answer. So we have five phases in a cement hydration. Firstly, there is an initial mixing. Whenever there is an initial mixing, there is a jump in the heat evolution. And then come the induction period. Induction period or the first period when there is a decrease in heat. Then come the dormant period, which is sometimes is part of induction period, sometimes we are taking it as a separately. And then when there is an active reaction or we are telling no, active hydration, that point is called as acceleration. And then after acceleration, when there is a hydration of other products, that is called as the post acceleration deacceleration process. And lastly, there is a slow continued reaction. So when is Ettingers forming? Whenever there C3A reacts with gypsum, Ettingers will form. So when C3 is actually reacting, whenever we are adding cement in water, the first compound which react with water is C3A. So when Ettingers is forming, actually is the pre-induction period or the initial mixing period. So answer is B. Okay. So the next question is, which of the following imparts gray color to the cement? So these are the different raw materials which are we are using to form cement: calcium carbonate, aluminum oxide, silicon oxide, and iron oxide. So which of the following compound will give us the color to the cement is iron. Mainly because of iron, we are getting the gray color in the cement. Otherwise, normally if you see the cement which have a very low amount of iron, it's called as a white cement. So the high amount of iron will give the gray color to our cement. The next question is, arrange in the decreasing order of percentage of composition in cement. So which will have the highest percentage in cement is C3S, right? After that, C3 or C2S, which will have more consider. Okay, so if we see the normal composition of our uh, different compounds of cement, we have 45 to 50%. Everywhere it is almost 45 to 50%. Not taking the type 4, type 4 is high alumina cement. So if we talk about the type 1 is the normal. So if we talk about the normal cement, which is a type 1 type of cement, we have high percentage of C3S, then C2S, then C3A, and then C4A. Right? So answer is A. Okay. So the next question is, what is the primary cause of excessive expansion in cement detected by the Leach-Aqueous test? So we are doing this test for the soundness of cement. So what exactly soundness tell about it? Tell us about presence of excess C3S, anhydrated calcium sulfate, free lime and magnesium, or high gypsum content. So I already talked about it. So whenever there is a free lime or there is a free magnesia present in our cement, So what will happen whenever we are adding water to our cement? This free lime will react with the water and can cause the expansion of our concrete. So which can be tested by the soundness test. Okay, so the answer is free lime and magnesium. So the next question is which hydration product is more susceptible to chemical attack? So these are the main hydration products: CSH, Portlandite, and Attendite. So different chemical attack. If we talk about carbonation or sulfate attack or acid attack, so which of these three type of hydration product will be affected mostly? So mostly if we talk about effect on the hydration product, it is always the formaldehyde, or we can call it as CH, calcium hydroxide. So okay. So whenever there is a sulfate attack, this calcium hydroxide will react with sulfates and will form calcium sulfates and sodium hydroxide. So what will happen because of formation of calcium sulfate and sodium hydroxide? There is a expansion in our concrete which will create the cracks in the concrete. And second thing is whenever there is a carbonation, chances that calcium hydroxide will react with CO2, it will form calcium carbonate. So if we see from the concrete point of view, calcium carbonate is a good thing because it is reducing the pore size. However, when we see from the durability point of view, this calcium, because of presence of calcium carbonate, the alkalinity of our concrete will reduce and there is a chances of corrosion of our reinforcement. So the answer is B, Portland. Okay. Okay. So the next question is: finer the cement, slower is the rate of heat development. It is true or false? If we have more fine cement, the heat development will be slower or faster. So answer is false. So if we have more fine cement, what will happen? The surface area of cement particle will increase, and whenever it will react with water, the heat of hydration will be much higher than the normal, uh, means the coarser cement. Okay. So how can type 1 cement be converted to type 3 cement? So these are the different type of cement. Type 1 can be converted to type 3 cement. So we talk about compositionally, what we are doing, we are actually increasing the alite concentration, right? C3 is called as the alite. No, sorry, C3S is called as the alite. Sorry. So we are actually increasing the alite concentration. So from these two, it is increasing the alite concentration. Second thing is increasing the fineness or decreasing the fineness. The answer is increasing the fineness. So if we increase the fineness or if we increase the C3S content, we can actually convert our cement from type 1 to type 3 cement. Okay. Okay. So the next question is, what is the significance of the fineness modulus of aggregate? So why we are calculating fineness modulus of our aggregate? It indicates the fineness of cement. Wrong. We are calculating it for aggregate. Cannot give us the fineness of cement. Measure grading of aggregate can be true. Determine water absorption from fineness of modulus. We cannot determine the uh, water absorption. Show aggregate strength. Fineness modulus cannot actually show the aggregate strength. So this is the apparatus used for the fineness modulus. We are sieving our aggregate using different type of sieves, and then we are calculating the fineness modulus from the formula given here. So what it from sieve itself you can tell the fineness modulus will give us about the different grading of aggregates. Okay. Yes. So the next question is the presence of flaky and elongated aggregates in concrete leads to improved workability, increasing strength, poor interlocking and low durability, or better cohesion. So, if you might have heard in the lectures, we don't use flaky and elongated aggregates in our concrete. Why? Because flaky means very thin aggregates. So, if we are using very thin aggregates, whenever load will be there, there are chances that the aggregates will break down. And elongated aggregates, what will happen is elongated aggregates, if they are kept at a certain angle, there are chances that it will create a uh, gap or hole inside the concrete system where there is a no mix or uh, a pore is formed, a gap is formed inside a concrete. So it can, uh, so what can be the disadvantage of using flaky and elongated aggregate? It is reducing the interlocking of our aggregates and will reduce the in long term it is reducing the durability of our concrete. Okay. So the next question is in high strength concrete cracks passes through the paste or cracks passes through the aggregate. So if this is our normal concrete matrix, if we have a high strength concrete, what will happen? If we have a high strength concrete, what will happen? We will have a very strong matrix. The force will be very less, and the bond between the concrete matrix will be very strong. So in this type of concrete, what will happen? Firstly, the aggregate will break through. There can be and the cracks will form through the aggregates, not through the cement paste. Okay. So the next question is alkali silica reaction occurs when aggregate contain excessive amount of carbonate, silica, sulfates or clay. So the basic definition of alkali silica reaction is when the aggregates have high amount of silica. These silica reacts with uh, alkalis of cement paste, alkalis of cement paste causing a ASR gel along the aggregate, and this ASR gel will expand itself and will form a crack. Okay, so because of excessive silica, we have a alkali silica reaction is because of excessive silica present in aggregates. Next question is for a given workability, the water demand is reduced. So it will result in higher strength, decrease in cement content, lower strength, or force in concrete mixing. So this is a statement given in the slide itself. When we are fixing a workability, imagine we have fixed a workability at 75 to 80 mm. from slum test. We have 75 to 80 mm of workability. We are reducing the water demand. So what will happen? The strength of our concrete will increase because if we are reducing water demand, less water will be there. However, the cement content will be equal only, and the hydration products forms will be more of CSH, will be resulted highest strength of the concrete. Next question is high range water reducer, which are also called as superplasticizer. They are primarily used for reducing curing time, producing high strength and flowable concrete, decreasing heat of hydration, or preventing corrosion. So this is a simple answer. We are using superplasticizer so that we have a more flowable concrete and have a higher strength of concrete system. Okay. So that's all for week 5. If you guys have any doubt, you can ask me now or you can mail me on my mail IDs. Any doubt? So if there are no doubts, then we will close the class for today. Thank you.